Alright, adding and subtracting rationals, expressions, day 2. Really feel like I've been on a roll lately, not making any mistakes, so you guys be ready to catch me on this one. Not sure if I can keep it going. Alright, when you have complex fractions like this, the best way that I have determined to do it is by simply rewriting it as a conventional division statement where you have 1/3 the numerator divided by the denominator, and then going back to the old keep change flip cycle that we've done when we simplified rationals that involved division in the past. So keep the first fraction the same, multiply, switch the symbol to multiplication, and flip the second fraction so that you get x divided by 9. Okay? I'm pretty sure I got that one correct. We'll assume anyway. Alright, moving on from here, notice that the problem gets a little bit more complex, but it's really not that big of an issue because we're still dealing with values that have a common denominator. The whole point that we're doing here is we're building up to numbers that don't have a common denominator, so we'll just go ahead and ease into it, as it were. Alright, so x plus 1 divided by x squared minus 1. Keep, change, flip, x minus 1 divided by x. The thing that you have to recognize here is that's a perfect square trinomial. Sorry, the difference of two squares. So that's going to be x minus 1 times x plus 1. Given that, I'm going to go ahead and cancel this one with that one, cancel this one with that one, and the final answer is 1 over x. Question number 3. You'll notice now we have encountered a value or a numerator that doesn't have a common denominator. So this is the whole point of adding and subtracting rationals day 2, is what we do when we encounter complex fractions that do not have common denominators. So the first thing you must do, whether it's the first or the second quantity, is find a common denominator. Don't do the keep change flip until you have a common denominator. Very important. Okay? Alright, so here my common denominator is 2x, so this side needs the 2 and this side needs the x. So that's going to be 6 plus x squared all over the common denominator of 2x. Keep, change, flip, now that I have common denominators on both of my quantities. Now I can go ahead and find my cancelable terms, if that's a word. We will rewrite this as x squared plus 6 divided by 2 times x minus 1. Nothing else can be simplified, therefore my answer is finished. Okay? As we move on through this practice, there is going to be more and more complicated solutions, or complicated steps to get to your solutions. So the first step is always going to be to rewrite it as a division statement rather than a complex fraction. Divided by 1 x squared y minus 1 over x y squared. Alright, the common denominator is going to be x y squared here, so I need another y, and on this side I need the x. The common denominator here is going to be x squared y squared, so in this one I still need the y, and on this one I still need the x. So now that's going to be y minus x over the common denominator of x y squared. Notice I'm still writing it as a division sentence. I haven't keep, change, flipped it yet. So now I have y minus x divided by this common denominator of x squared, y squared. Now that both of my quantities have a common denominator, it's okay that they're separate common denominators, but each quantity has its own common denominator. Now I can do the keep, change, flip. Y minus x divided by xy squared multiplied by x squared y squared divided by y minus x. Big cancel party here. These quantities are gone. This cancels out with that exponent right there, leaving me this guy, and those two cancel out entirely, which means the solution to this is x. Alright, question number 5. We have 3 divided by x minus 4 divided over 1 minus 2 over x minus 4. The common denominator here is going to be x minus 4. So that means that this guy needs the x minus 4 over x minus 4. So now I get 3 over x minus 4 divided by, notice I haven't changed this yet because I haven't made my common denominator. Avoid combining steps because then it's easy to make a simple mistake. Minus 2, all over the common denominator of x minus 4. Now I can go ahead and keep change flip. 3x minus 4 times x minus 4 divided by x minus 6. Combine like terms. Cancel party. These quantities are identical, so the final answer is 3 divided by x minus 6. One last problem before you are free to work on the rest. This one at first glance looks like I'm just going to flip everybody around. These guys go downstairs, these guys come upstairs. That is not the case. Please be very careful about this. This is actually 1 over x plus 1 over y, still in the numerator, and 1 over x minus 1 over y, still in the denominator. Now I've created my complex fraction. Now I'll rewrite it as a conventional division sentence. Minus 1 over y. Alright, my common denominator here is xy. My common denominator here is also xy. So this guy's missing a y, and this one's missing its x, so on and so forth, all the way across. Alright, now I get y plus x divided by the common denominator of xy divided by y minus x divided over the common denominator of xy. Keep change flip. Y plus x divided by xy times xy divided by y minus x. Cancel. And the answer is y plus x divided by y minus x. Alright, questions 7, 8, and yes, 9 are your problems to practice. Please note, number 1, that you rewrite them as a conventional division sentence. Number 2, find a common denominator for the first quantity, then a common denominator for the second quantity. Once you've done that, keep change flip to multiplication and cancel any quantities or numbers that are identical. Good luck. Come back to class tomorrow with these 3 problems finished, or a series of good questions that you found in trying to solve these problems without my assistance.